OK，它已经开始了。
开始了。
对，它已经开始了。
Okay. Anyway, we'll get the process started. Whoever is making the noise, I'll kick you out. That works. Okay, I should say that earlier. Okay, so I think there should be a delay something because my computer is running too many things. It is starting. Okay, so okay, let's get this started. So we have Tony here. He's the advisor of Ampligence. He has been with the company from the beginning, since literally the very beginning. And today he's coming to our office and giving us a talk on how to write good code from his 30 years of experience of writing code. So let's give him a hand.
Thank you. First, I want to apologize that these slides are very crude. John just invited me a couple days ago, so I just kind of put something together very quickly, and this is barely a rough draft. So I apologize for how crude things are. So I just have a few slides. I want to go through them fairly quickly because I'd like to spend most of my time just talking with you. I think just having a discussion would be more valuable than you just sitting there watching slides.
Yeah, so for those of you with us remotely, feel free to unmute your mic, and if you have something to speak, just like as if you are here present.
And also on the screen right now, I have my email address, so if anyone has a question, thinks of something after we're done, or has a question, just feel free to email me and I'll get back to you. And those below, there's a few of the things that I've worked on in the past, but we're not really here to talk about that. So anyway, what's good code? Well, first off, good code needs to be correct. It needs to do its job properly, and it needs to do it in a reasonable amount of time and using only a reasonable amount of system resources. Another aspect of good code would be it's reusable. Parts of it should be able to be used in other projects if at all applicable. Every time you write an application, there's going to be parts of it that are somewhat general, and it could be useful to separate those general parts from your application so you can reuse things. And I'll talk a little bit more about that later.
Yeah, actually, coincidentally, that's what we have been doing today.
Okay.
So we have been writing code in an unorganized way, and today we try to separate out those part of the code that can be used in every project.
Refactoring. Now that John mentions this, I think refactoring. I wish I had a slide in there mentioning how important refactoring code
Yeah,
is.
so we pull all the common code into its own project.
Perfect.
Yeah.
That's perfect. Then it's more easily reused in a different application. And I'll go into this a little bit more. And also, it's also possible that you might want to be able to reuse the code on different platforms. Windows versus Macintosh. But in your case, would be more applicable to Ampligence is your two platforms would be your client applications and your server. So there might be some code that you want to share between the two. And then also the real thing, and where I intend to spend most of the time, is on having code that's maintainable. Because this is the real expense. Software has a lifespan, a life cycle, and the real expenses come a year, 2 years, 3 years down the road, not necessarily today. So things that you can do today can have a big negative impact down the road.
Or positive.
Yes. So you want the code to work, and one of the important things is when you make modifications to the code, you don't want to accidentally break something else. So I'm a big fan of having test code, that every class, every module, different major pieces, they all are able to be compiled separately in a little console application that can run these scripts that feed different inputs into it and test the code, make sure everything is working. So if I change some code in one area, in one class, I don't accidentally break the code somewhere else. And because I'm only testing in this one little area, I don't notice that. I check it in the version control, and then I've broken parts that other people are working on. So if you have a lot of test code to exercise all the different parts of your program outside of your application, this can be very helpful. In general, it's called test-driven development. It's one of the things I like. And the reason I like to do it as a console app outside the application, because that makes it more convenient for testing, especially you can automate it. You can set up a script that automatically builds and executes your code in the middle of the night, runs all your tests, and then in the morning you get a little report that, oh good, everything's still working, nothing's broken.
Yeah, so here at Ampligence, we use C# and we use NUnit for testing, as we have been doing this in the workshop.
Good. So, and it's also something that's, it's also polite to your coworkers to run the unit tests and whatnot, before you check things into version control, the source code control, to make sure you didn't accidentally break something. Just a little polite thing to do. So, reuse. One level of reuse is using other projects. We were talking about this just moments ago. Little example where I'll have two different applications, and they both may have Mac and Windows, and then some shared code that is specific to the application. But notice there's also this general directory outside of the applications where that's where I would put code that is very generic. It's not specific to any particular application. So you can think of it as it's your own little library that your company will develop over time. So you have a little company library that over time, has bits and pieces of useful things. And it's good to reuse that rather than just every application create something that does the same thing, and you have as many different implementations of the same sort of thing as you have applications. Basically, you want to avoid redundancy. If you can have code that's shared between applications, if you can have code that's shared within an application but between the different platforms, different operating systems, that's really good to do. One of the things that one of those small things that people sometimes do as a shortcut that can have very negative consequences is they just copy and paste. It's like, oh, this is just 5 lines of code, 10 lines of code. I'll just copy and paste it, and it'll just take a few seconds and I'll be done. And sometimes, even though it's only a few lines of code, someday there'll be a bug. You'll have to track down every damn instance where this was pasted. It becomes really awkward. So reusing code as much as possible is helpful.
So here we are very strict about copy and paste.
Yeah.
I don't ever allow copy and paste. Cut and paste is okay, but never copy and paste.
Yeah, well that's right, because then there's only one copy of something. Something's
Yeah.
only in one place.
So we actually, it has a name. We call it the dry principle, DRY. Don't repeat yourself.
Yes.
So
yes.
so every time I say dry, like people, they know they repeated something.
Good. So, and also, same thing, I mentioned the other platforms.
Let me check. It might broke. The Skype connection might broke. I heard the Skype. Oh, it's all done. Let's continue.
So, another thing about other platforms is don't necessarily try to do things the way you're used to on one platform on a different platform. You know, if Apple recommends you do things one way for Mac OS and iOS, and Google recommends you do something slightly differently for Android, and Microsoft wants you to do things slightly differently for Windows, just go with Apple, Google, Microsoft. Go with what the native thing on the platform is, and that normally makes your life easier. I mean, you have to do a little bit of relearning sometimes at first, but in the long run, you'll probably experience less pain by just going with how the vendor who developed the platform suggests.
Can you elaborate on that?
For example, trying to think of something that would be more meaningful for you here, but I can't think of anything offhand, but I'll just speak in very general. So if you go into the Apple code or into Apple's SDK for iOS or Mac OS, and you look at how they want you to create a little local database to save information, they'll have example code and they'll want you to do it a certain way. Google will have a similar thing on how to store things in a local database, and the code might be slightly different. One might be using MySQL, Google might be using their database technology, and you might think that maybe I'll just try to make the Apple code that's dealing with MySQL work under Android, and it'll probably be less painful in the long run if you just would use the native Android database that Google's developed. I think Firebase. Firebase is what I'm trying to think of. So Google likes to promote, Google acquired a database called Firebase, and thank you. And they sort of promote that and recommend people use that. So if you see Apple recommending to save things locally with MySQL, because that comes with Mac OS and iOS by default, and you see Google recommending to do something different with and use Firebase, just do it that way. Yes, you could get MySQL to work under Google and under Android if it doesn't already. It may already by default without you having to do anything. But if Google's recommending Firebase, it'll probably be less trouble over years if you just do it that way. What might be more relevant for you would be, you're using Unity, so Mac OS, iOS, Windows, you don't really care because Unity can target all of those for you. So Unity is really your platform, except on the server side where I'm going to guess that at some point you'll have some Amazon Web Services code, probably written in Java, and Amazon will have, suggestions of how to do things, the best practices. So the best practices under Unity might not match the best practices under Amazon Web Services. So you probably it's safer to go with the best practices of each different platform rather than trying to emulate one platform on the other. Oops, I think I lost my keyboard.
Oh, maybe do it manually. Or maybe it's just... Okay, now okay, now you gets back. Okay.
Okay, so now we're getting into maintainability. So basically, code should be easy to read. It should almost be as easy to read as a book. So if you use very descriptive names for your functions, your variables, your classes, then that helps making the code readable. You know, short little cryptic things can work, but your brain has to spend a little bit of time parsing that and interpreting that, and that little bit of activity of your brain kind of adds up, and it's fatiguing. So if you can make things more readable, your brain can more readily absorb the words and understand what the code's doing. That's less fatiguing, and it makes it a little bit easier to read the code, to work on the code.
Yeah, I want to add to that. So I think somebody actually did a research on this.
Yeah, absolutely.
So the time you spend writing the code to the ratio you time spent reading the code actually is 1 to 10. You spend 10 times more time reading your code than writing your code from your daily activities.
Is that just you? That
No.
doesn't count all the other people who are going to have to work on it later?
No, somebody, yeah, that just for an individual,
Yeah.
individual. So
So it's worse than that. It's more than 10,
Yeah.
because other people have been too.
So even if just for yourself,
Yeah.
it is 10 times make your life 10 times
Yeah.
easier.
So, having a code formatting standard, that makes it easier to read. I could give you some examples on like a whiteboard, but it's not that important.
常说 whiteboard.
Okay.
It's not terribly important, but also using white space to break up things on the same line, break up multiple lines. Marker. Okay. Thank you.
那个好像没水了，
就2只没了。
那个好像没水了。
So, I'll use an example that drives a friend of myself crazy. So, example of the code formatting is where you put the opening brace on like if and while statements. Do you put it on the same line as the if, or do you put it on its own line, lining up with the if? So, I personally don't care. You know, I'll have, you know, the argument in the research is about how easy it is for people to line up this closing brace with the beginning of the code. Personally, I can line it up easily whether you put the opening here or here on its own line, because I'm mainly paying attention to the indentation. But some people
Like me.
want to see the matching opening brace. So this sort of code drives them crazy, and it makes them, it breaks their habit of how they find the beginning, because they're trained to find the beginning by finding the opening brace, whereas I'm trained to find the beginning by finding something at the same indentation level. So, you know, having a coding standard is important. When you do this, this works for everyone. This works for people like me who are just going by indentation, and it makes people who are looking for the opening brace, it makes them have to spend a little more mental effort to find the beginning. So if you have a standard that does something like this that works for everyone, then it's more efficient. So, you know, you want to conform, you know, the company should have a standard, and you want to conform to the standard because that's polite for all your coworkers. And also, as you're reading through the code, if, you know, you'll naturally adapt to whatever the standard of the code is. So if you're reading along and all of a sudden something is very different, that jars you and it kind of distracts you, and it actually, I believe the research has shown, it slows you down as you're reading through the code.
Yeah, so actually, just to echo on that, this will drive me crazy.
Yeah.
So we at Ampligence, we definitely use this style.
Yeah. So this is just one of my favorite examples, because I have a friend who's just like you. You know, this just absolutely drives him crazy, whereas I don't care, either one works great for me.
Yeah.
You know, but I concede, if I do it this way when I'm working with other people, it works for them, it works for everyone. Whereas if I do this, I could be annoying my coworkers.
Yeah. So the good thing is, we use Visual Studio Compiler, so the
Yeah,
formatting is automatic.
Yeah. So you want to make the code as easy to read as possible. White space, if you have, A plus B and there's no space between those three things, the brain has to spend a little more time breaking those apart and interpreting what they are. Whereas if you put spaces between the operands and the operators, that creates a natural separation, and it's just slightly easier for the brain to parse that and to tell operands away from operators. And then also you can use vertical spacing, where if you have 3 lines of code that are doing one thing and then 4 lines of code in a function that are doing something else, maybe put a blank line to kind of separate them, just so that visually you're kind of indicating that they're doing something a little bit different, or they're working on different phases at different stages. It helps making the code readable, and so your eyes can move over the code faster and more easily interpret what you're seeing. And then here, names. When you're naming your variables and functions, it's helpful to give them, longer names. We're not stuck on 80 by 25 text terminals where we have to, try to make our code fit into a very small space. We have these nice big monitors today. We can have 120 characters on a line. We can have 50 lines on the screen. We can use longer names and make things more readable. So, and a nice thing is, if the names of your variables and your functions are designed well enough, sometimes they're like a little bit of a comment themselves, because they make it more obvious what the code is doing. And so ideally, if the code is easily readable enough and understandable enough, then your comments are more describing why you're doing something. They're not having to explain the code so much. And I have a little example. This is point and rectangle, tap position, play button location. And then comparable, there's just, inside tap play. They both do the same thing. And the latter example, the inside tap play, that's not bad. It's still, pretty easy to recognize what it's doing. But your brain has to spend a little more time interpreting it and making sure it's done so correctly than the longer version, which is more explicit about what's going on. That, is point in a rectangle, we're checking the tap position and the play button's location. So the names of that function and those variables are telling me, oh, this code is checking to see if someone has tapped on the play button. So it's kind of a comment just in the naming convention.
Okay, so regarding the naming, so we actually invented a term like half joking, half serious. We invented the name CNO, which means Chief Naming Officer. So Tony, from your 30 years of experience, how do you view the importance or necessity of this person?
I think that's similar to having a coding standard that everyone abides to.
More about
So if you have a judge. So if there's a disagreement, so normally you wouldn't need your CNO. Mm-hmm. Normally, you talk amongst yourselves, bounce ideas, because like one of my friends at Blizzard, he recently posted to Facebook because he was trying to come up with a good name for something, and and he bounced it inside his team, but he wasn't happy, so he put it on his Facebook account, so all his former co-workers who've worked with him over the last 15, 20 years, he could get their inputs. And so, so sometimes this can be resolved just by talking amongst yourselves, you and your co-workers. It shouldn't have to go to the CNO,
Or-
but it's good to have this referee, this judge, that if the team can't come to an agreement on its own, it's good to have someone who will make the judgment call, the way you had to do with your coding standards. That maybe the compiler has certain coding standards built in, but they're configurable. So you could have a judge for coding standards who could go into the compiler and change the syntax layout, the automatic coding layout of your integrated development environment, to conform to whatever was that. So you kind of probably have a judge for both the coding standard and names and other things.
Yeah, I actually realize you might not notice this because you're native to this, but keep in mind that most of the programmers here, English is not their native language.
Right.
So sometimes it might be difficult for the non-English speakers to come up with a suitable name. So I think in that aspect, how do you view the necessity of the CNO?
Well, I still think first you don't have to bring the CNO into it. I still think the individual programmers can just get together two or three. If someone is newer to English, they can just talk to one of their coworkers who's more experienced with English.
What if the coworker is also non-English?
Well, then at some point it escalates. But this is something that can often be taken care of informally at lower levels. I guess all I'm really saying, it doesn't always have to go to your CNO. A lot of the times it can occur at lower level. But something we'll get to later on when I talk about code reviews, that's where someone like a CNO might step in and say, we need a new rule about how we format code because of something I see here, or we need a new rule, or we need to change some naming that I see in this code. So having someone like the CNO involved in code reviews can be important to make sure that decisions that were made at a lower level were stronger. So another thing about functions, it's really helpful if they only do one thing. So if the name is describing one thing, it helps if that's all the function is doing. You don't really want to have side effects. You don't want to have some secondary functionality, some secondary behavior that this function does, because the name is not implying it. If you read through the function, you may see it, but it sometimes happens that someone will use that function and not understand that there's something else. There's the secondary behavior that's going to occur.
So I think sometimes it's inevitable to have some side effects.
Then the name should, the name should reflect that.
Yeah, then the side effect should go into the name.
Yes. Then the name should somehow reflect both things that are occurring. So basically, you don't want any surprises. That you read the function name, you have an idea of the sort of things this function is going to do. When you read through the code that implements the function, you shouldn't be surprised by anything that happens in there.
So by being not surprised, I think people name it the principle of least astonishment.
Yeah. So another thing, a general software engineering idea is code becomes unmanageable and has to be replaced as it grows in complexity. Eventually, a project will hit a certain level of complexity where it's cheaper to throw it away and write it from scratch with the experience you have than to try to keep the existing code working.
That is what we are doing now.
Yeah. And one of the things that leads to that is complexity. And one of the metrics of complexity is connections between things. So a connection could be a function call. A connection could be a variable that is shared between two pieces of code, two functions, a global variable. Class, how many public members a class has. So if you can reduce these connections between classes, between source code modules, reduce the number of variables that have a large scope or a global scope. You may have to like think about how you want to organize things. You may have to think about how you want to write this code a little bit more, because, you know, frankly, just adding a new connection is one of the easiest things to do. But if you think about it, is it really necessary? Can I do it some other way without adding a new connection? That's good for the longer lifespan of the code. That lets you get, you know, some extra time before you reach that point where the code is so complex you got to throw it away and start over.
So, Tony, would you say if somebody introduces a bad class that suddenly introduce a lot more connections, would you say the code is better off without the code altogether?
Possibly, but that's like, you know, that's one of those things where, you know, the idea of refactoring, going into existing working code and rewriting it to make it simpler, even though the code's working, refactoring says go back and improve it anyway, make it simpler. So if you have a degenerate, troublesome class that's like that, you go back and refactor it, make it simpler, improve it. You want to do that with all code, but if a code is messed up and that complicated, then the refactoring is more of a, we have to do it. We have to do it soon, rather than, you know, we'll do that next month when we spend a few days refactoring. So sometimes, you know, refactoring could be something that is like a schedule, like, you know, once a month we're going to spend a day or two refactoring old code, improving it. And that's just part of your normal work behavior. But sometimes you might find a code, like a class that you just mentioned, that it's so complicated that becomes a special case, an emergency, and you say, we're going to refactor it now. So the number of connections to between things, that's something you really want to minimize. That's one of those things the research shows is a very strong metric of complexity. And code reviews, you know, everybody's code should be reviewed. Even if you're like the greatest programmer on earth, somebody should be reading your code. You know, nobody's code should be going into the project without someone else also reading it. And this is a good time for not just making sure, you know, that second pair of eyes, that second brain is going to see things that you don't. There might be a bug there that, you know, you've read the code 100 times and you've just not noticed the bug, and someone else looks at that code and it just stands out to them. So having a second pair of eyes, a second brain go over the code is very valuable, even for just debugging. But it also double checks things like, you know, we talked about making sure the code is readable and understandable. Same thing there. The person could, you know, might, in part of the code review, they might point out something that they think is a bug. So then, you know, you go over the code and you make sure it's not a bug, or you fix it if it is. But they might also say that, you know, I had to study this code for a few seconds. You know, it didn't, you know, maybe we could come up with better names to make what it's doing more apparent. So the code reviews are both for debugging, but also fixing or improving the code in terms of readability and understandability. But code reviews are also something that should be, you know, part of the schedule. That, you know, every piece of code that's going to ship to a customer, it has to be reviewed. It can't just go out with only the original programmer having written it. And also the other important thing with code reviews is it's also a good time just to ask a question. If you see something that's kind of interesting or you don't understand, you ask the other person about it, they explain it, and all of a sudden it makes sense. Code reviews are also a great learning opportunity. So, you know, personally, I think, you know, a third of what I've learned through, you know, formal training, universities, and other sort of formal experience.
The schools.
Yeah. But then another third is just from self-study going out and reading serious books, serious literature, learning new programming languages on my own. But another third is just from your coworkers, from your peers. You show them your code, they show you their code, you understand it, you compare, you learn from each other, you explain things to each other, and that's also another valuable source of learning, are your coworkers. So code reviews not only improve the code, but it also improves your skill as you're explaining things to each other and you're asking questions of each other. So, being kind to your fellow programmers, and then I also include in that yourself a year from now. You write some code, you don't look at it for a year. When you come back to it a year later, it's like you're a new programmer sometimes. You look at your code and you don't quite understand what the heck it was you were doing a year ago. So, and so some of the things, making everything very readable, very understandable are important. Version control, I assume you're using some sort of version control. Yeah, that's, even if you're alone, even if you're the only person, you're working on a project alone, no one will ever see this code other than you. You still want to use version control. It's insanely, incredibly useful, even for yourself when you're working alone. Using namespaces, so
So Tony.
Yeah.
When you use version control, is there like a rule of thumb? How often should you commit? Not push, just commit.
Even when I'm working alone, I tend to do the commit when I get to a little milestone where something's working. I don't like to commit things that aren't finished yet, that's broken. I like to commit things when I've made a little bit of progress, commit it, and then continue on. So let's say you have a to-do list, you want to implement, 3 pieces of functionality. You're working on one, that doesn't necessarily mean I'll commit 3 times. I might commit like halfway through something where I have something partially implemented, the code's working, but now I'm going to experiment. So I'm not sure, I've done a little bit and it's working, I commit it, then I'm free to experiment. I'm free to try something, it doesn't work, I don't like it, I'll throw it away, revert to what I committed earlier and start over. So it's kind of like sometimes it's like a little backup point where it gives you the freedom to experiment, try things, and throw them away if they turned out to be a bad idea, and you go, and you just and you back up.
So every time you want to do some experiment, you want to commit first before you try.
Yeah, and also in a team environment, when you're going to add new functionality, you'll sometimes want to create a branch so that you're off on your own little branch, and so everyone's working on different functionality. Maybe you're all in different branches. Maybe 2 of you are working on the same functionality, so two of you are on that particular branch. But you kind of want to use branching to kind of separate each other's work, to avoid interfering with each other.
And also, so how often should you push?
Pushing, that's something, for a team environment, I would merge, I would run all my regression and integration tests, and then I'd push. So, I would not only, run the application, make sure the new thing that I added is working, I'd want to go back and run my regression tests, my unit tests, and make sure I didn't accidentally break something somewhere else in the program as part of my merge and my new code before I do the push. So for pushing, I think a whole extra level of testing is necessary in a team environment, and that's why I like to have the regression tests and unit tests and whatnot, so I can manually run those after I've done a merge, but before I've done the push, to kind of make sure that I didn't break something unexpectedly. Thinking before you type. my very first programming class, Intro to Computer Science 101, this part-time system administrator who was teaching the class, wasn't a regular professor, he said one of the most important things in, undergraduate and graduate computer science education. He said, the more you think before you type, the better your code is going to be.
Yeah, actually, that's the first day I know Tony. Tony has been telling me this.
And again, yeah, that was like, this system administrator for our Unix mainframe was made to teach the Intro to Computer Science 101 class one quarter, and he just had this basic simple idea that was just one of the most important things I got all through bachelor and master's program, is that the more time you spend thinking before you type, the better your code's going to be. So that could be about what data structures you're going to use, what algorithms you're going to use, interfaces to other code. Just get a piece of paper and a pencil and just draw a terrible little graph about how you want the classes to connect, or the classes or the different parts of the program to talk to each other. It doesn't have to be anything fancy, just a little personal exercise, just you kind of running through it on paper before you start writing code. It really can be helpful. And because that's part of the design. It really helps to think about the design and having a fair idea of the design in your head, even for little things, before you start typing.
So Tony?
Yeah.
So here we have this workflow order. So we first write the interface,
Sure.
then we write the testing.
Yeah, test-driven.
At
Yeah.
last, we finally write the implementation.
Yeah, no, that's test-driven is one of those ideas that I like. Yeah.
So interface, test,
Yeah.
finally the code.
Yeah, yeah. But even before you type that, for some things they're simple enough, you can go in. But sometimes even just drawing a little sketch on paper with a pencil, just to make the idea clearer in your mind before you start typing the interface and the test, can be helpful. Programming languages, you don't have to use every single feature. Sometimes, as we learn programming languages, we learn about some new functionality and we think, oh, that is cool. That is something that sounds great. And then we kind of make up an excuse for using it where we probably shouldn't have. And sometimes the code gets more complicated and harder to read and harder to understand for other people because you made that decision. So sometimes, I don't want to mention the project, but in C++, templates are very powerful. And templates can be used very, very well. They're a very good tool. But sometimes a beginning C++ programmer, someone new to templates, they'll overuse it. And it'll actually have performance and other drawbacks. It also makes it harder for some people to figure out the code. And it turns out to be counterproductive. So sometimes, you use an advanced feature of the language, and hopefully you thought about it and you made a good choice. But this is another reason we want to have the code reviews. Sometimes during a code review, someone will say, perhaps it would be simpler if we did it some other way. And be open to that. Yes, this functionality in the language might be very powerful, but you sort of need to balance the power of the language with the simplicity of the code, the understandability of the code. And this is often a judgment call. There's no real hard rule. It's just something, you kind of have to make a judgment call on. Hopefully you get better over time with experience as to how much of the language to use. If you talk, like C++, for example, has a reputation of being a very complex language. And if you sit down with the C++ book and you try to read the book and learn all the features, yes, it is an absolutely incredibly complex language. But if you talk to an experienced C++ programmer, a lot of the time will tell you, I often only use a fraction of the language. That, for my normal programming, there's a lot of functionality in the language I won't even use because I don't need it. It just makes things more complex than it needs to be. And that's something you'll hear very common. So sometimes you learn something new and you want to try it because it sounds like fun, it sounds like cool, but maybe run or write a fun little program at home that does this. Don't necessarily do it at work until you're sure that it's actually making things easier, not making things more complex.
Okay, so the C++ template is actually known as generic in C#.
Okay.
So and actually when you use generic in C#, it just like a monster that creates unnecessary coupling. So is there some rule of thumb when it's a good time to use template, when it's the bad time to use template?
When I've used templates, it's usually a very small function, and it's very polymorphic in nature. It's something that I want to apply to many different type classes. So, probably one of the classic examples of a template is, min and max. You do min and max as a template. You have templemized parameters, and so you can use it with integers, with floats, doubles, a bunch of different numeric types. And that's, probably one of the simplest examples of a template, a generic. And uses like that are more appropriate. If things are like, if I see a template that's getting more than like 1, 2, or 3 lines of code, I start wondering if something's wrong there, and I'll like pay more attention to the code. But even if it's short, they can sometimes be misused. Not that I necessarily. There's still an improvement over like macros in the C language and the C++ language, where it's literally a preprocessor doing string, global search and replace, because that has a whole set of potential problems. I'm not sure if C#.
We don't even allow macros.
Good. Yeah. No. Between const and type defs and templates, macros are kind of like a legacy thing that's not really needed. But they should. So templates and generics should be really short, simple things that it's very natural to want to use them with different types, and it makes sense. Things like min and max are the classic examples. You really don't want to get the project that I referred to before. It had templates. It had nested templates, and they were, some of them were like 20, 30 lines of code each, and it was just a mess.
Nested templates is a nightmare.
Yeah, if you're doing nesting, that's a good time to step back and go back to thinking and postpone typing, or sometimes to stop typing and then go back to thinking.
Yeah. So you said don't use every feature of the language.
Yeah.
What are some of the features you recommend us to never touch it?
That I don't know. Like in most code that I write, I don't bother with templates, and that's. And I think in a lot of like experienced C++ programs, they'll say, they don't use templates a lot. They don't use, multiple inheritance a lot. They might use single inheritance, multiple inheritance, not so much. It's not that like the feature is bad. It's just that it's often not appropriate. It's something that's powerful, but it's something that can be used inappropriately, and so that makes it a little bit dangerous. So I guess we've talked a little bit about always writing tests. You know, everything should have a test, especially things that are public. You know, when something's public, that's part of your API. You know, an API, it's kind of like a contract. You're promising other programmers that here's some code that's going to do something. So that's something you always want to have a test verifying that it's correct. And again, that's where I like to, after merging and before committing, I like to run all these tests to make sure all the APIs, all these public functions, you know, are still working properly.
So how do you write private tests? By definition, they cannot be called.
Well, because I have a separate program that I'm gonna.
Need the whiteboard?
No, I don't need it. I was gonna silence my phone, but it's mostly buzzing, so it's probably not being picked up. I have my common code that is at the core of the application and has nothing to do with the platform. One of the reasons I like separating platform code from application code is because so that the application code, you know, in your case, the application code would be code that doesn't need to interface with Unity at all. So here's a dividing line in your source code. Here's code that needs to communicate with Unity, and here's code that does not. So I would like to have them completely separated from each other. And the code that does not need to talk to the platform, does not need to talk to the operating system, basically. I would have that, I could build that with a little text console application, and then the text console application will run scripts that exercise that code. And then, to give you an example, so like one of the applications that I did for iOS was, you know, a calculator. And so, and the calculator has like, you know, scientific and business and programmer hacks and statistics and some other functionality. And one of the things that I did is I drew a line between the user interface and the core calculator code. And the interface between those, I decided were going to be button presses. So my interface from the core code to the platform is, you know, a button press. So there's one function for pressing the 1 button, the 2 button, the 3 button, the plus button, the equals button. All the buttons that exist on the calculator, there's a function that is the interface for that. And so when someone's using the application, they press the object on the screen, and that calls that interface function, and that interface function goes into the core of the calculator code. So, but that keeps the calculator code independent of the operating system. It doesn't know or care if a real human being pressed the button, or if the button is being pressed by a script. It doesn't care if it's running under Windows or Mac OS or iOS or Android or Linux. It doesn't know or care. So, but the nice thing about that is I can have a script, I can compile that against a little console program, a trivial like C function, C with a main program that is literally just reads a text file and feeds numbers and pluses and equals into a little function that converts that into the appropriate button presses. So I can just create a text file that, you know, it'll be a regression test. It'll exercise all the different buttons, all the functionality that the calculator offers. I can put that in a text file, run that through this little console program, and this console program, I can have it running on a headless Linux box in my closet. And the nice thing about that, I can also do what's called fuzzing. Fuzzing is where you create random inputs. So for the calculator example, I would create random numeric values and random operations, feed those into the calculator code, see what the result was, and then I would feed those same random operations and operators into like a GNU scientific library, and I would compare the output of the GNU scientific library with my calculator code and make sure, you know, the results are for 11 or 12 significant digits, they match each other. And the neat thing about that is, so when I reach a particular milestone, I can compile my little Linux console app on the machine that's running in the box, or the Linux box that's running in the closet. No keyboard or monitor attached. I just SSH into it from a Mac or Windows PC. I can just let it run. I can let it run, build and run the regression test every day, and I can let it run the fuzzing test over the weekend, where it just spends the whole weekend creating random operators and operands and just running them through the program and making sure that everything works out. And so that's sort of an advantage of separating the core application code from the operating system, which in this case I would consider Unity the operating system. And you could probably do something similar here. I'm going to turn off some stupid alarm that's going off on the phone. So you could, if you separate some of your core mathematical code, you could have some sort of external scripts that run that have a problem, create random answers, create random attempts to solve the problem, and just have this little console program just feeding all these random attempts to solve the problem. Let it run over the weekend, and come in and make sure nothing crashed.
Yeah, actually, up to today we haven't even opened Unity yet.
Yeah, so if you can separate the core functionality of the application, the math, the problem solving, all that sort of stuff, keep that completely isolated from the operating system, the Unity code, then that gives you the option of being able to create these stupid little Unix-based console tools that you can let run on a server over the weekend, and be part of a continual testing process.
Yeah. So one thing is.
So and that gets to having the public functions, this public API, that is testable, but that testing also can go into other forms of testing like scripting.
Yeah. So my question is, actually I forgot my question. I answered the other question. So if it's private, how does it get called?
There I'll usually have some sort of friend. Like in C++, you can declare for as a friend. Well, then I'll make the test function part of the class, and sometimes the test function might be defined public, and I might use conditional compilation. So I might have something that is only compiled into the program if I'm building a test version as opposed to the retail version.
So it's like if debugging, then it's public.
There might So there might be some debugging code, some testing code that's in like the if debug.
So is
that becomes public. So it's conditionally public.
Is that a good use of macro in that case?
Yes, for something like that. Yeah, that's probably about the extent of using macros. But again, you need to have the macros use in that context part of your coding standard. Because are you going to test that if the macro exists at all, or are you going to test that the macro is true? It's set to 1 versus 0. So is debug defined, or is debug true? You want to have that. You want to have that defined in your coding standard, so everything's consistent and someone doesn't, accidentally do the wrong thing.
Yeah, actually,
I went back one.
I think the Skype got disconnected again. Just let me connect that. So actually, join call. What? They kicked me out? Oh no. Let me connect my So that's also what I call putting the front end to the back. So
Okay.
so we put everything in Unity, we put it to the back so we can do exactly what you said.
Good.
Okay. So okay, let's get back to
It took a second last time. There we go. Okay.
Is the keyboard still
Not
connected?
yet.
Is the keyboard still connected? I see a
No.
keyboard lost. I think we finished this.
Okay. Yep. All right. Okay. So we're talking about writing good code, but sometimes you don't have to write good code, or you don't need to. It's rare, and I think I mentioned this because sometimes people think they don't have to write good code too often.
曹叔啊 SBM SBM
So, if code is going to be discarded, if it's like you're going to use it once and throw it away, and it's never ever going to be used again, then it doesn't really matter how well it's written. But funny things happen, and sometimes this code that you thought is only going to be used once ends up getting used again in the future. Sometimes you have a demo or a minimum viable product that you're in a hurry. You're just going to get this minimum functionality. It's mocking up and faking a lot of things. It's little more than a slideshow to communicate to investors, potential investors, how this thing's going to work. It's not a real program. It's not solving the real problems. It's kind of faking it to a certain extent. Well, that sort of code, maybe you don't have to put the extra time in to do it right. You don't have to do, your regression tests and your code reviews and all that.
or like you're in a hackathon.
Yeah, something like that. But one of the traps, one of the mistakes sometimes people make is we're behind schedule and we need to catch up. That's not the time to relax your standards and start writing fast code instead of good code. This kind of turns counterproductive very quickly.
Yeah, actually, there's a good analogy for this. So you're out of time, right? Imagine a doctor, a surgeon, is doing you a surgery. Okay, the doctor is certainly out of time. Like your stomach is cut open, right? The doctor has limited time, right? But it doesn't mean because the doctor is in a rush, the doctor should lower its standard. Do you want the doctor who is in a rush cutting your stomach to lower the standard just because it's out of time, right?
Yeah. So a lot of times, this happens a lot of times. People think I gotta make shortcuts. I gotta take some shortcuts to get myself back on schedule. And rather than take shortcuts and write code that's not so good, you're probably better off just talking to the manager, project leader, and explain the situation. Say, this is taking a couple more days than I thought, so I'm a little bit behind. You and the team are probably far, far better off if you just go have that uncomfortable conversation and mention, I'm just a couple days behind where I thought I'd be, and not try to take shortcuts to catch up.
What if there is a dead deadline?
Well, by dead deadline, that's kind of like what I'm getting to next. Like, we got to have this done by this date, or we are literally out of money and the company shuts down.
Okay.
Unless you're talking that sort of catastrophic deadline, I think taking shortcuts gets overused. Taking shortcuts, I think, gets used too many times because of inconvenience or embarrassment, to tell the truth, as opposed to you're in this terrible, terrible situation where, we're out of money and we got to get paid for the next milestone. and so we got to get to that point by this date.
And even if
And that, I mean, it shouldn't happen, but being realistic, it does happen. And so sometimes you got to take shortcuts, and you got to do the bad thing, the wrong thing, to survive.
and when
It
you
happens.
and when you do that to survive,
Yeah.
after you survive, you have a lot of refactoring to do.
Yes, you're going to pay for it later. But if you don't survive in the first place, it doesn't matter. But unless your survival is on the line, shortcuts will usually do more damage in the long term than be helpful. But we're also getting into one of the lies that, okay, I'm going to take a shortcut now, I'll come back and fix this later. Well, later you're going to be busy too. Later you're going to have a schedule, and you might be worried at getting behind schedule on something else in the future. You're probably not going to have the time to come back in the future. So don't lie to yourself and say, I'm going to take this shortcut now and come back later and fix it. Because you're going to be just as busy, just as troubled by your schedule later as you are now.
Okay, so for that, I know my browser is like this, and probably many of your browsers is also like this. My browser has like 30 tabs open because I will read them later, right? But later I will have even more web page to read.
Yeah.
So this never works.
Yeah, and same thing happens with code. Related to that is, okay, you did your demo, you did your MVP that kind of faked its way through a demo, got you farther along. Now you're going to write the code for real. And you start thinking, well, maybe we could fix up that MVP code, that demo code. That doesn't always work out so well. If you wrote code with the intention that it's going to be thrown away, you probably should throw it away. It probably would. You'd probably end up with better code if you just, wrote something from scratch. And and then also related to that, there's also the idea of you're working on a project, you're working on a program, you finally finish it, and you're looking at it later, and you got better ideas on how you do it. So you go, if I was going to do this program all over again, I have new ideas. I got a better idea of how I would do it. And I would do a better job second time around. And you'll rewrite it someday. And then even then you'll have a third realization of even a better way to do it a third time. And so sometimes just throwing it away is the right thing to do, because code that was supposed to be thrown away, throw it away, rewrite it, because you'll probably have better ideas now than you did back then. And you'll end up with better code in the long run. And then also, don't think that you can do something sloppy, quick and dirty, fast, because you're the only person who's ever going to look at it, or you're the expert in this area of the program. No one else is going to want to look at this part of the program, because a year later you're going to look at it and you're going to be scratching your head wondering, what was I thinking here? You won't remember. You did something tricky, you forgot what that trick was, and you don't even understand your own code. That happens all the time. So even when you're writing code for yourself, write it as if for someone else, for some other coworker to have to pick up where you left off and work on it.
But by the way, that's an excellent way to keep your job. If you're the only one on the planet who can understand this code, they cannot fire you.
No, they should fire you and have that code completely refactored.
Yeah.
Anyway, I think that's it. Or my keyboard lost. I lost my keyboard again. Is that the last slide?
That's the last slide. It's already the last
Okay.
slide. That's why it didn't.
Good. All right. So, I don't know. Just here's the good part. Just questions.
So now let's open up for questions. Or if nobody's asking the question, I'll be asking the question.
Yeah, we asked a bunch of questions during the talk, and that's fine with me. I like that. I prefer, even in the middle of the slides, I prefer interaction.
So,
Move closer to the camera now.
Okay, this is my personal question. Do you know any backdoors for like StarCraft, Warcraft, and Diablo?
Um, there aren't any, as last nothing intentional.
Nothing intentional. Okay.
Nothing, because everything we do, people will discover.
Okay.
No matter what we put in the code, people will discover it and figure it out.
Mm-hmm.
So if we put some sort of backdoor in there, they would find it.
It's already figured out.
Yes.
Okay.
Because you know, I add code to help with security. You know, to help make things harder for hackers and cheaters. You know, they figure it out pretty quickly.
Mm-hmm.
You know, everything is discoverable. Everything gets discovered. There's people that they a patch comes out, they start doing differences to find every little bit of code that changed between, you know, one patch and the next patch,
Mm-hmm.
and they analyze it pretty closely.
Okay.
There are things that are called Easter eggs
Mm-hmm.
that are normally hidden. They're little surprises, but they're put in there intentionally. They're put in there, so it's okay. We talked about conditional compilation.
Mm-hmm.
So there's things called cheat codes. Some cheat codes might be like an Easter egg, but cheat codes in the sense that it gives you more health, gives you some weapon, those are things that are usually wrapped in conditional compilation so that they're only part of internal debugging builds, that they get excluded from the code when you're building something that is going to go to the public. So there's nothing in the shipping games that would allow an insider to give themselves more health, more points, more weapons, more armor. Nothing like that.
Okay. It's both a good
'Cause-
news and bad news.
Yeah, because it would be discovered. If it was there, it would
Yeah.
be discovered.
Okay.
These games are such high profile, people are constantly analyzing the code. It would be discovered. And the Easter eggs are all discovered. There's plenty of websites that tell you every single Easter egg in the game, because people will go in there and analyze the code and figure it out.
Mhm.
But the Easter eggs are normally, they're designed. You type in something and a character does something funny, or something funny comes on the screen.
Okay.
Those are intentional. They're designed. They're intentionally coded.
So, suppose, is there any rule or preference how to divide tasks to many programmers?
This is one of those things that there's great debate. There's one argument that you should assign the person who has the most experience in that sort of area. But there's another argument that you want everyone to work on all the different pieces a little bit. Part of that is kind of related to your code reviews, that, different people will see different things. Different people will learn by looking at someone else's code, by looking at a different part of the program. So there's an argument that you kind of want to have everybody work on the different pieces a little bit to kind of do cross-training. Because if only one person works in one area of the program, they're sick for a week, there's bugs, they got to get fixed, it would be nice if someone else was familiar with it. So, maybe there's like some middle point, that some person is the expert on that area. They work on that code 75% of the time, and then other team members kind of take turns working with them side by side, maybe collaboratively, a couple days a month, something like that, just so some other people get a little bit of familiarity with the code.
So
maybe there's a balance. And then at the far extreme, there's some people that argue it's completely random, that there should be no there should be no favoritism, no specialties, that everybody should be assigned to the different parts of the program equally. They should spend the same amount of time in all the different. I don't know if I go that far.
Right. So for
I think something between those extremes.
So for the particular situation of our company, what do you suggest?
You know, it sort of depends on how you want to organize. Well, first of all, there's like a big dramatic difference. You know, there's one natural separation. There's separation between the user interface code and, you know, the core mathematical code.
The front end and back end.
Yeah. So that might be a line where, you know, you do have some specialization. Because someone who's familiar with, like, you know, all the user interface elements and widgets and how you glue them together to make the user interface, and how you process the various events that are coming from the user, and that translates into operations that are in the game. The front end stuff and the back end are two very, very different specialties. So for that, it may make more sense to have a little bit of separation. But within user interface, within the mathematical, within like server side, maybe those are areas where, you know, you can have some experts, but you don't want, but you want people to join and work with the expert in a particular area every once in a while. So everyone might, you know, so no one really owns anything. So sometimes some projects, people have this idea of ownership, that, oh, don't work on that part of the program, that's so-and-so's, he'll get pissed off if anyone else ever touches it. You don't want that. You don't want to have something where someone is the owner and no one else is allowed to touch it. Now, someone could be the expert and they work on it most of the time, but I think you want other people to work on it occasionally also.
Okay, let's open up for more questions. For the Skype people, if you want to speak, remember to unmute your mic.
Hopefully I did not put people to sleep.
Hopefully.
I want to ask a question about the program.
Louder.
Sure.
So, what kind of design do you think is the best? Because you know, I think the design is the most important part when you're writing an application. And what the feature of the good design do you think?
Oh, sorry. Could you repeat that again? The last part.
I mean, what kind of design, what features does a good design has? Do you think is the most important feature for good design?
For good design of the user interface, the code.
I think he means a good metric for good code, right?
Architecture, the product, architecture, I think.
This is, if it's a metric to kind of evaluate how good.
Is that
Was that your? Okay. That is an active area of academic research in computer science. It is an unsolved problem.
Yeah.
There are some things. There are some metrics that are used in software engineering that like suggest something specific, like complexity, like the number of connections
18 classes.
is can indicate complexity. The number of operators and operands in a function, just the raw counts could indicate the complexity.
So
Could
normally,
suggest the complexity of that function. But you know, I kind of lean more towards the human evaluation than the mechanical evaluation. That if you read code and it's good, you know it. A human being will recognize good code by reading it.
So the readability is one metric.
Yeah. So if you can define an API and you can tell a programmer, here's my API to this sort of functionality, then that kind of tells them a little bit about your design by understanding the interface. Then, they can read through, maybe you'll let them read through the code and they can see how things are implemented. I think if good code would be approachable and somewhat readable and somewhat understandable by someone that's new. Maybe they don't understand, maybe there's some like complicated physics or mathematics behind something that's working this way. You can say, well, here's a formula. We're given this formula. We don't understand why this formula works, but this is what we have to work with, and so we've implemented this formula. And they can, read through the code and judge easily whether that code is implementing that formula. So not necessarily that they understand the physics or the science behind something, but they can kind of understand the code. So long ago I worked at a company doing chemistry software, and this one very high-level researcher in polymer chemistry saw our application, liked it, wanted to use it as the front end for Dow Chemical, the front end to their legacy software. They had this polymer chemistry computational stuff written in Fortran running on mainframes going back 15, 20 years. Nothing wrong with that code. It did this chemical analysis beautifully. There was no reason to change that code, but they wanted to have a more modern user interface. So they wanted to use our graphical Windows application to let people build molecular structures and then submit it to the back end to this old legacy Fortran code. And, I had 1 year of chemistry, so I was the person who was, I was the computer programmer who had 1 year of chemistry. So I was the interface to this famous PhD at Dow Chemical, and he liked working with me because I knew just enough chemistry to be literate in chemistry, just barely enough that he could communicate with me. I didn't have to understand what was happening in the chemistry. He would tell me something and I would trust him. But I could read the code, I could read the Fortran code, and I could, understand it if it was doing what the PhD researcher was telling me was supposed to be happening. So you have a design that is supposed to accomplish some job. And if the code is written well, a person should be able to read through that code and at least understand if it's meeting that job. They may not understand the job. I might not understand the chemistry, but I can understand the code and make sure that I don't break anything in that code. And that was a scary project because we actually ported it from their mainframe to Windows. We actually had their chemistry code running in Windows. We got Microsoft. Microsoft had a Fortran compiler at the time, so we created a little Visual C++ Windows. We created a little Windows app. See, their Fortran program started by asking for these 6 parameters and a file for the molecule. And the 6 parameters, just basically 6 numbers that they typed in, would customize the computation. So we just created a little Windows dialog that had 6 text boxes where you entered in the numbers, and I validated them the way I knew the Fortran code was validating to make sure they'd be accepted. And then I just plugged those into the Fortran code and let the legacy Fortran code run under Windows. And I was so scared. Like, oh, please God, let the numbers come out the same as on the mainframe, because I don't know how I will ever debug this if the numbers don't come out the same.
There's no way to debug.
Because I can understand the code, but I don't understand the chemistry. So how am I going to go through the code and But fortunately, that old Fortran code just worked beautifully even when it was compiled to Microsoft Windows years later. But it was readable and it was understandable. I didn't understand the design from the chemistry point of view, but I could understand the code. And I had a chemist telling me in vague enough terms what was supposed to happen that you know, that I could, you know, so I would understand the code and I could see the code was doing what it was supposed to.
Yeah, and also just add to that, please comment if you agree or not. There are a few more metrics, well-known metrics. One is, I mentioned earlier, the principle of least astonishment.
Yeah.
So just count how many times you surprise other programmers, and that's the indication how good your code is. And another is called law of Demeter. So you only ask for what your class should only ask for what it really needs. Don't ask for any additional things. Don't ask for things indirectly. Don't ask for something to give you that thing. Just ask for that thing directly.
Yeah. Sometimes when people are writing code, they'll add something to a class to make it convenient for the programmer, not because it's necessary that the class have that. That if I just have a public function that does this, then it's easy for me to implement that functionality. But that's probably not the way I should have done this. The way I should have done this would involve more work. So I made this class more complicated, gave it more connections to make life easier for the programmer. That's usually the bad idea. Should always think of the code first. And if doing the right thing in the code is going to make a little more work for you, the programmer, you know, too bad. But also, I think having other people look at the code and tell you this is good code, I think that's probably the most reliable metric. I don't think there is an automated software-based tool that can be as accurate. They can probably tell you if code is bad. That's, you know, maybe they can tell you there's too many connections, there's too many operands and operators in this function. So but that's all. But I don't think that's as well developed as a human opinion.
Yeah. So I think for speaking.
It's like reading a book.
Yeah.
You know, you read a book.
If it's a good.
You like the writing. You think the author is a good writer, or not. You know, versus having a computer analyze, you know, the text.
That's what they do for SAT.
Yeah.
They value your SAT writing using an algorithm.
Right, but they're just looking for a cheap shortcut to save money.
You save money.
Yeah. Now, okay. Well, okay. There's another. Okay, engineering, software engineering. So, one of the principles of engineering. So this is one of the things a software engineer is supposed to consider is the good enough solution. This is the perfect way to do something, but maybe it's too expensive to do it that way. Here's something that is good enough that's not going to be as expensive. So when you build a bridge, you know, a bridge is going to have a certain lifespan. You know, the engineer is told this bridge has got to last 50 years. This bridge has got to last 100 years. This bridge has to carry, you know, so many kilograms of load. So good engineer, okay, this is the maximum number of kilograms the bridge is supposed to support. Well, I'm going to triple that in my design. This is the number of years that the bridge is supposed to last. I'm going to double that in my design. So now I have a safety margin. And, you know, but in software you can make those sort of decisions too. That here's a perfect solution. You know, for like NP-complete problems, a traveling salesman problem. We can write a program that will find the perfect answer, but that solution is going to have to basically try everything, try every possibility, and see what's the best. But maybe we can come up with a heuristic, but that's going to be too expensive of a calculation. The salesman could drive in a car to all the towns in the time it would take the computer software to figure that out. So maybe we come up with a heuristic that it doesn't give you the perfect solution, but it gives you a decent solution, a good enough solution. So sometimes, you know, in our design, we have to make that decision that, you know, here's the perfect way to do something, but here's something that's good enough. And I think that's what the SAT is doing, that the computer software is doing a good enough job at telling you whether this essay is good or bad. But if you had an honest-to-God English professor read it, the English professor would do so much better than the computer software. But the English professor is much more expensive than the computer software. But I think we're still at that. So maybe there is some use to having software rate, or having a program rate source code. Maybe there is some utility in that, but I don't think it gives you the best answer. Maybe it would tell you if you had a really bad day. So if you had a really bad day programming and you wrote some terrible code, maybe it's good at the negative, but not necessarily good at the positive. I don't know, but that's still, I believe that's still just an open research question that professors are writing many papers arguing with each other about.
Or there can be a keyboard counter, like count how many times you smash your keyboard. That's an indicator,
Yeah.
right?
Well, and that's one of the neat things with open source, is because people get to look